In this next part, we're going to look at hypothesis tests. Now, we haven't done any hypothesis tests yet with two variables, and so we still are going to have all the things that we had back in our prior studies dealing with a single variable, such as a null and alternative hypothesis, an alpha value that determines what our cutoff is for our p-value, calculating a p-value, we're going to use StatKey to do that again, and then making a decision as to have we reached statistical significance or not, and what that means. So still a lot of components involved as we do this. So we're going to start out with the null or default claim when we're dealing with a matched pairs situation. The default or null. We're dealing with quantitative data in this situation, so we're going to continue to use mu as we previously had. Now, in the past we've been a little bit lazy about using subscripts to describe mu. Now that we're getting into two variable analysis, we are going to be very careful about doing that every single time. We're going to watch for that we do that. So we're going to put a subscript here on mu to clarify exactly what that mu stands for. And it is the average, mu is the average of the difference between medicine A minus medicine B. And if I were to just write A minus B down there, that would suffice as well. So we're going to have that information right there. And what mu is going to be equal to is what we would expect the difference to be if it was the default assumption, meaning that medicine A and medicine B had no difference. If you assume that medicine A and medicine B are equal, you would expect that for any given pair of twins, the difference in their cell counts is going to be 0. So for each pair, maybe one twin's a little higher with medicine A, but then you'd expect maybe another pair to be higher with medicine B. You would expect the average either way to still come out to 0. So we're going to say mu is equal to 0. We're also going to write the alternative. And the alternative is going to look just the same as the null. It's going to have mu. It's going to have medicine A minus medicine B as the subscript describing what mu stands for. Note that this is still a single mu, still a single average. It is not multiple things here. It is just a description, so we know what it means. And it's going to be something compared to 0, just like we always do. We just have to choose our symbol. Is it going to be greater than, less than, or not equals? Now, in this particular situation, we didn't have any assumption that one of these medicines was going to be better. So in a case like that, you would use the not equals test. If let's say we designed medicine A and medicine B was some existing product that we thought we could do better than, we would assume that medicine A was better. And in that case, we would say greater than to imply that we think that for any given pair of twins, medicine A was going to do better than medicine B, or have a higher result. So we would say greater than. In that case, if it was the opposite, we wanted low numbers, we would say less than. So in this case, not equals. Our cutoff value is typically going to be 0.05. That's the highest we will allow our p-value to get before we're a little bit too worried about being wrong, about the results coming out and us not being confident enough in those. So 0.05 means there's a 5% chance of rejecting the null hypothesis when we should not have. To get our p-value and then to make a decision with that, we're going to need to go to StatKey. So for our p-value, we are going to go and enter in the data that we have. We have our list of differences that we entered in as a confidence interval earlier. We're going to go back. We are still dealing with a single quantitative variable, a single list of numbers because of the matched pairs. And we're going to do the hypothesis test now, test for a single mean. Again, this is something you've done before, calculation-wise, but we're going to interpret differently. So we paste in that list of differences, and then we have our null hypothesis that we need to change to mu equals 0, which is what we talked about earlier. So we enter that in, and now we're going to generate our resamples. Since the null is that mu is equal to 0, most of our data is going to clump up around 0 here. And we are going to, because of the not equals test, we are going to say it is a two-tail. If we thought greater than, we'd go right tail, less than, left tail. And instead of setting the middle to a certain confidence level like we did with confidence intervals, we're going to instead set the end here to match our original sample mean. So our original sample mean was 3.25. And in this case, that's going to be closer to this end. So I'm going to set that to 3.25. And we are left with 0.016 as probability of being above that sample from our null hypothesis. Same thing on the other side. So because it's a two-tail test, we're going to add up both red regions to get 0.032. So let's go ahead and do that. P-value is 0.032. Based on that, we need to make some decisions. The p-value is less than alpha. That means that we get to reject the null hypothesis. So we are going to reject the claim that there is no difference between medicine A and medicine B in favor of the alternative claim that there is a difference. So we will say that there is a difference. That is what we now believe. The last thing we need to think about is whether or not when we found this link, we can say that there is cause involved. So whenever we see a link like this, whenever you get to reject, there is a link. So there is a link. There is dependence. And what that means is that the type of medicine you have and the blood cell count are connected statistically. We think that one is linked with the other. Now, is it the cause? The only way you can decide if it is a cause is if this came from an experiment. So if these twins were found as volunteers, they were split up into the two treatment groups randomly. There weren't major lurking variables present, such as telling them which type of medicine they were getting, which could lead to a psychological bias, things like that. If all of that was run as a proper experiment, then yes, you would say that there is a cause, which means that the type of medicine you take does cause you to have a different number of blood count, different number of blood cells. If it was not run as an experiment, then all you would get is the link or the dependence. You would not have the cause. So the experiment is what gives you that last little piece that says, I know why this link occurred.